but you should have watched it, where she talked about the engineering design process, where we do project identification, then specification development, then conceptual design, detailed design, and then delivery. And we have to go back and forth in these phases to make sure that we get it right. It's not just a step-by-step process. What we're going to talk about today is specification development. So we're going to be in these first two phases, the project identification phase and the specification development phase. I want to emphasize to you that these two phases should likely take the most of your time throughout your engineering careers. Because, like I emphasized with the communication lecture that I did, the most important thing is to know your audience. In the design process, the most important thing is to know your audience or your customer. So we are doing that in these two phases. Then the next phase that we'll work on after we've made this concrete is the conceptual design phase. This is when you start to come up with ideas. But you should not get to this phase yet until you understand what's happening. So I don't want to hear any ideas for solutions yet. We're going to work on specifications today, but no solutions at all. Got it? By the end of this class, you will understand how to fully define your problem, write a voice of customer, identify the customer for your project, develop a strategy to complete research on your project, transform what we call needs into requirements, prioritize those requirements, create an objective tree, and turn needs into specifications. It's a lot of stuff. Hopefully we get to it all. So we're going to start with problem definition. This is what you come up with, and you've kind of already been given like a problem definition because you've all been assigned to projects already, and there's like a brief statement about your project. But you're going to need to come up with a slightly less brief definition of your project. It's broad, but it doesn't have fluff. It's not just going to be a fluffy statement. It has meaning, but I want to emphasize that it should not have any solutions in it. It's called solution neutral. So in this problem definition, you do not suggest a solution. You want to ask a lot of questions in order to be able to develop this definition. And you really aren't going to be able to put it into concrete words until after you've done all of your research. So that statement that you've been given so far is just a beginning. And you're going to continue to develop this problem definition and define your problem throughout the next few weeks. Actually, you might even all the way up until the end of the semester. Because the more you learn about your project, the more you can define it and you can iterate and change it. Then we also do what's called a voice of customer. This is also known as our problem definition, but it's from the viewpoint of the customer. It's written in their voice. It clearly defines your problem in 1 to 4 sentences. Again, it's done after you've done all of your research, but you write it from the point of view like, I'm a person with a disability sitting in a wheelchair. You actually write it as if you are that customer and telling you what it is that you need. It's never written in stone. Just like that problem definition, you can go back and change it. And you should go back and change it. I'd like to see that you are thoughtful enough to go back and change these things after you've learned more about your projects. In order to be able to do this then, we need to understand who our customers are, or also known as our stakeholders. I know I say this a lot, but I can't ever emphasize it enough. Understanding your customer is the most important thing to this process. You really have to understand what it is that they need. But in order to do that, first you have to understand who they are. What are the needs then of each of the different customers? Because you might think that you just have one customer. Can someone give me an example? What projects do we have in this class? I forget. What are you guys doing?
Schedule.
The schedule. Okay, so who do you think might be the customer for that? Who was the person on the right side? Was that Dr. Romatowski?
No.
Oh.
I can't think of her name. Your sister,
Teresa.
Teresa. Yeah.
Okay, so that's probably your primary customer. But as Jackson was already getting to, there's other customers involved. So as part of your research and what you'll do today with your groups, you need to brainstorm who those other customers might be. You're always going to have a primary customer, and that's probably the person off on the right side of your project description. But then you're going to have your secondary customers. So anyone who is affected or involved with your project is considered a customer or a stakeholder. Not only do you need to identify who those people are, but you also have to identify what it is that they need, because they're all going to have different needs. Their example, Teresa, has one need, whereas Jackson was saying students might be another customer under your project. They're going to have completely different needs. Teresa needs to be able to look up where classes are at any point in time so she can maybe schedule other classes, whereas students just need to know where they're going. So that's the kind of thing we're looking at. You're going to all have different types of customers, and they all have different types of needs associated with them. So keep a reminder that your customers are not just the final end user to your product or your solution. There can be lots of other people, like who else might also be involved with this? The janitors. Housekeeping might need to understand when they can get in and clean the rooms. Other products, who makes the product is a stakeholder. Who has to maintain the product is a stakeholder. All of these types of things. So let's do an example. How an airplane should be designed really depends on who you talk to. So if you're talking to the salesman, they want an airplane that has a lot of people, but also entertains all the people. It has a pool, and it has a beach deck, a place where you can play volleyball and mini golf and all this kind of stuff, so they can sell it. So that's what they want out of an airplane, whereas maintenance wants it to be as simple as possible, so they can easily just do their work, right? Airports want it so that they can land in a tiny space, because then it's more affordable for them. Pilots want a nice big cockpit, so it's fun for them, or more comfortable for them, we'll say. Service crews want all of these gadgets to help them be able to do their work. Accounts want to fit as many people as possible on that plane so they can make money. Engineers just want something that's awesome. I mean, that's awesome, right? That's pretty cool. And operations want something that uses oil. So every customer has different needs and wants for the product. Now, do any of these actually represent what you see on an airplane? No. So there's a compromise, and designers have to consider all of the inputs, all of the stakeholders' needs before they come up with a final solution. So take a couple minutes and talk with your groups. If you're not with your groups, you need to go with your groups. Talk with your groups about who you think your customers are. And don't forget, you don't just have primary customers, you have lots of different people. But keep thinking about that, and you might have to update it. Just because you came up with a list today doesn't mean that list is not going to change. I can't emphasize that enough. Forever. Throughout the process, things should be updated all the time. Now that you know your customer, you need to consider what it is that they want and what it is that they need. There are a few ways that you can gather this information. You can do what's called indirect research or direct research. Indirect would be doing research like looking at patents, what's already out there. On Tuesday, we're actually going to have our librarian come in and teach you how to do patent searches, because it's not as easy as just typing in a couple of words in Google. It's much more complex if you want it to be effective. You can also look at journals. Journals are most of them are online these days, but these are where people have done research and they're publishing their information, and it's reviewed by their peers. So it's supposed to be valid and all that kind of stuff. So it's really good to look at journals. I think that's a good resource. You could also look at government reports, newspapers, that kind of stuff. Textbooks, print materials, that's all indirect research to get information about your customers and what their needs are. But then to do direct research, you can do things like interviews. Find someone and actually interview them. Do a questionnaire or a survey or a focus group. Let's talk a little more about indirect research. We're going to look at how to look up patents, because I think that's important for engineers to be able to understand what a patent is and how to find those. But another way that I really like students to do some indirect research is go out and see what's already out there to solve your problem. It's likely not that you will just use that as your solution, because we've given you this because we are not happy with any of the solutions that are currently out there. But it's a good place to start. And then we do what's called benchmarking. So when you start looking at these different types of things that are already out there, you can start making a list of like their advantages and disadvantages. What is it that makes it good? What is it that makes it bad? So that you can try to improve on those current solutions. I gave you a list here of a bunch of different websites that are good resources for finding things. But if you're doing you can also go to Walmart and see if they have any products. Or if it's a medically related device, Main and Locust has it's a pharmacy down here. They have a section that has this kind of stuff. Be creative. You can also look at other industries. Have you all heard my example about the aneurysm device that I designed? If not, I'll remind you. I was in a group where we were designing a device to treat aneurysms, which is a bubble in a blood vessel in your brain. We were trying to figure out a way to make it so that it wouldn't, once it bursts, the blood is then flowing out of it. So we were thinking about different ways to stop flow of a liquid. And there's a lot of different devices already out there to do this in vessels and all that kind of stuff, but it was a rainy day and we saw someone walk by with an umbrella and that stops fluid. It's like, well, you're not going to use an umbrella and stick that in your brain, right? Not exactly. But that's actually what we ended up designing, a miniature umbrella that gets deployed up into that aneurysm to stop the flow. So thinking outside the box and looking at other industries and how it might be able to apply to your problem is a really cool way to go and could be helpful. I already talked about journals, government reports, newspapers, demographics. All these things fit into kind of a category of looking at reports, stuff you can Google or go to the library and find. Any questions about that? It's a lot easier if you go into this search for indirect things, if you go in with a plan. It's kind of the rule of thumb for anything in life. If you go in with a plan, it's a little more efficient. The biggest thing I would suggest before you just start Googling things is to come up with keywords. Brainstorm as a group keywords that you think might be effective and useful for searching for things. Then I would also suggest assigning different parts to different team members. Like someone's going to go and look in journals, someone's going to go look at patents, someone's going to go to Walmart. You know, assign different things so then you can come back together and share your ideas. Write summaries as you go. So instead of just kind of coming up with a list, also write a couple sentences about each thing that you find or each piece of information, each piece of research, so that you have that information. Great thing to go into that design journal. Share it with your group members regularly. Make sure you're getting together, talking with your group members on a regular basis so that you're effective and doing a good job as a team. And then that also helps you to come up with other ideas, piggybacking ideas. Maybe Hunter found something really cool at Walmart, and so that makes you think that maybe, Matt, you could go look at patents and try and find the patents for that. So you're piggybacking different ideas. Now, how do you do this more tricky thing, that direct research? The whole philosophy of doing direct research is that you have a customer, you're the developer, so the customer is feeding information to you, but then maybe you're feeding it back to the customer as well. So you have this loop that you need to work within. The first thing you need to do is gather your raw data from the customers. So how do you do this? You do interviews, surveys, email questions, that kind of stuff. And then you have to interpret the data. If you watch the ethnographic research lecture by Dr. Senjum from Tuesday, he talks a lot about gathering information from customers. It's kind of how that fits in there. But you have to remember that you have to interpret it. So a customer might not know what they don't know. You're not going to just go and tell them they're wrong or anything like that. But if they say it needs to be lightweight, what does that mean exactly? They aren't likely going to know 10 pounds, 20 pounds, 40 pounds. But you need to be able to figure that out. What is lightweight to your customer? So it requires some sort of interpretation. And then going back to the customer. So if it needs to be lightweight and you think that's 10 pounds, you take a 10-pound something to them and see how they feel about it. Does that really mean it's lightweight to them? Well, you might find that it's not. It just depends on the customer. So you're getting this loop of information. After you've interpreted the data and you come up with these ideas or these needs, then you have to figure out which are most important. Because sometimes, even though lightweight might be important, you might not be able to make that constraint. So what is more important? The functionality? Is there something else? So you need to know the relative importance and then reflect on it. How do you gather that information? You can use interviews, focus groups, or observation. Likely the two that you will use are interviews or observation. We probably aren't going to put together focus groups. So actually go in prepared to these interviews where you have questions already ready. Go in and talk to the customer. And then observation, I really like this one, especially, does anyone in here have the handicap development one? No? Well, go in and observe a process that's already being used, or just watch what's happening. It's useful sometimes. How do you interpret that data? So what you need to figure out what, not how. So the customer might say something like, why don't you put protective shields around the battery contacts? Well, that's kind of already suggesting a solution. Your customers are going to do this. They're going to suggest a solution. But as a designer, you need to understand that that's not the way to go. So you need to interpret that and figure out, well, what are you trying to get out of that exactly? So the need statement, instead of saying the screwdriver battery contacts are covered by a plastic sliding door, this has a solution in it. You cannot have solutions in your need statements. Instead, you say the screwdriver battery is protected from accidental shorting. That's really what they were getting at. They want that to be protected somehow, but you don't necessarily have to do that with a plastic shield. So don't suggest the solution. Figure out how to make that statement so it's solution neutral. Here's a whole bunch of examples on how to make those statements and interpret that information. So what are needs and what are requirements? Our needs statements are vague, like we had back here. The screwdriver battery is protected from accidental shorting. There's no quantitative data in there, so that's a need. It's very vague. Whereas our requirement statements then have detail. But neither of these have solutions in them. You want to tease out all of these things by asking a lot of questions. You're going to get really good at asking a lot of questions. And realize that you might have a whole table of needs and requirements for one customer and a whole other table for needs and requirements for a different customer. They may have completely different needs and requirements. Requirements are a wish list that the product needs to do, or your solution needs to fulfill. It's usually given by the customers or sponsors, even as a requirement in the designer's mind. They're not usually technical, so we have needs, requirements, and then we're going to develop those into specifications, which then are technical. So a coffee cup is something that will hold coffee. That would be a requirement because it's not technical. All right, step 3, establish your relative importance. You need to have this because later on, after you've brainstormed ideas, you weigh those ideas and figure out which one is the best, and you use this weighting to figure that out. So we'll deal with that later, but do know that it is important that you have some sort of weighting or importance in there. You can also indicate whether it's a demand or a wish. So you can have two types of things, binary, 0 or 1. So it either fulfills it or not. You can have that kind of requirement, and you can have one that has a scale. So it's 1 through 10. Like 10 is the most important, 1 is the least important. So you can have both of those types. You can have your customer rank their wishes. That would be a good way to get that in there. You can use a Kano model, we'll talk about that later, or get it from your customer. This is an example of a way to do that. You prioritize your requirements. So D or W would be demand or wish. So D, these are all binary. They have to be part of the solution or it's not a valid solution. Wishes are things that they want in there or they would like to be in there, but they have more of a scale. So then you change these to importance. The binary ones all have 10s. They have to be there. 10 is the most important. Then these others that are wishes have a scale to them. So 8 would be the next highest. That one is close to being a demand. You get it? Good? Then, after you've created this list of requirements and you've rated them, then you reflect on that. Ask yourself some questions. Have we interacted with all the important types of customers that in your target market or that are related to your problem? Are we able to see beyond the needs related only to existing products in order to capture the latent needs of our target customers? So, are you looking beyond what's already out there to try and figure out what your customer needs? Are there areas of inquiry we should pursue to follow up? Which of the customers we spoke with would be good participants as you move forward? You might find people in the beginning that you start getting information from, but then you go back to only one of those with your product to test. So you want to identify those that might be good for that. What do we know that we didn't know when we started? Are we surprised by any of this? I hope that you will find that you are surprised. I think this is my favorite part of the process where you're really learning. And I hope that you'll find that you didn't know things that you thought you knew. Did we involve everyone in our own organization who needs to understand the customer needs? And how might we improve the process for future efforts? So how are you going to improve this? So take a few minutes with your groups now and brainstorm questions about your problem. Brainstorm questions, external questions about your problem. So things that you might ask other people, things that you might ask yourselves, and then discuss what the needs are of each of your customers, at least to get started. Discussing what you think those are. Develop a questionnaire, so start coming up with questions you're going to use as an interview. Brainstorm keywords for indirect research that you might do, like you're Googling. And then come up with a plan for how you're going to conduct your research with your groups. You can have 5 minutes or until it starts getting quiet. Do you feel like you have a plan for conducting your research? Okay, good. We'll move on, and I think we'll finish up fairly early, so it'll give you time to work on that memo project charter that's due at 8 a.m. tomorrow. The next part of developing your specifications is to consider doing an objective tree. This is where you come up with a list of your design objectives. And it's kind of the same thing, almost the same thing as your requirements and specifications, but what do you want it to do? And then organize them by relation. You know I'm a visual person, you all know the flow chart we have for our curriculum. That's because I love doing that kind of stuff. So I think of the objective tree as a lot like a flow chart. You come up with these objectives and specifications and then connect them and show how they all go together and make a tree. You can order them into higher level and lower level objectives so they have some sort of hierarchy, and draw a diagram. So this is an example of an objective tree for a water purifier. Unfortunately this is a solution, so you don't want to get to that point yet. But it needs to be safe, it needs to be cost effective, and it needs to be efficient. So those are the top level objectives for this solution. Safe, what does that mean? It needs to be safe for the environment and safe for the operators. So you have two components under there of safety. Cost effective, it needs to be affordable to produce, and low maintenance. Both of those things go into your cost effectiveness. Efficient, easy to repair and does the job. Those two go under efficiency. You see what it does? See what you're doing? So you're breaking it down into these different objectives and it becomes a tree. Pollutants disposed of properly. Chemicals are contained. Inexpensive material, affordable for customers, short time to correct problems, detect chemical imbalances. So hopefully you can develop a similar objective tree for your project. Then finally, we're going to talk about your specifications. This is where I feel an engineer differs from a different type of designer, because we like things to be quantitative. Okay, this is where we're developing those needs and requirements into something that's quantitative. And the reason I like this in particular, because it gives us then a quantitative way to see how we did in the end. So if you say it needs to weigh 10 pounds or less, when you've developed it, you can weigh it and compare it. It's awesome, right? To be able to have a quantity that you can compare to. So if you're 10.5 pounds, you didn't do it. Close enough, probably. But if you're 20 pounds, you can say, well, I didn't fulfill that requirement. Do I need to go back and fulfill that requirement or not? That's a very simple one. There's a lot of other things that are much more complex that you can do. All right, so your specifications consist of a metric and a value. So 10 is a value, pounds would be your metric. So you have a way to measure it. I do this an activity with kids on how to develop specifications, and it's kind of fun to try and say, what's a value? What's a metric? You all got that though, right? I mean, you're in college. You got it? Okay, good. Metrics are usually derived from functions, needs, requirements previously established. I keep going back to lightweight, but lightweight, how do you measure weight? You put it on a scale and you measure pounds. Then you establish these using different methods. You could use the performance specification method. I'm not really going to talk that much about methods. I think you guys can figure this out. These are some different metrics that we use for our specifications, like geometry. How do you describe an object? You can talk about its size. You can talk about its height, length, diameter, space, a number, arrangement, connection, extension. These are different things. Kinematics, forces, energy. So here's a table of all different ways that you can measure different specifications. Here's an example. If we have dimensions, we can say it needs to be 20 by 20 by 10 centimeters. This is for an automatic can crusher. So if we're trying to specify that it crushes cans, we want those cans to be 1/5 their original volume. So that's giving it a metric and a value. So actually putting it into quantitative measures. It needs to weigh less than 10 kilograms. A sales price of less than $50. And see, we also have these less than or greater than types of things in here. So you'll want to develop this type of stuff for your solution as well. Finally, this is the last piece, and you're going to want to develop one of these, maybe not for your memo for tomorrow, but in your next report, you're going to have to do something like a QFD chart, or what's also known as a house of quality, because we're then going to use this to assess our products later on. So you may as well start it now. So right now, you're going to start with your customer needs. You're going to create a list of your customer needs, and then you develop those. This down here is your relative importance. So those 10s, 8s, 1s, all of that kind of stuff goes in this column right here. And each of your needs is in a row. Then you develop those metrics. So it needs to be lightweight. So it needs to be less than 10 pounds. That goes right here. And then you can show how they're related to your product that you come up with, or what we call benchmarking, and we'll do that at a later time. So you don't have to worry about any of this stuff yet, but start off with this table here where you have your customer needs and you're turning those into engineering metrics. And then you're going to show how they're related to each other. A lot of times you might just have a direct correlation, but sometimes customer needs might be covered by more than one metric. That's the idea. So you have the next 20 minutes to work on your memos, to work on your research, that kind of stuff, as a group. So don't waste this time. It's a great opportunity to get your work done that you need to get done.